n be a positive integer. Prove that n is even if and only if 13n plus 4 is even. Okay, so there's two parts to this proof. The first part, we're going to start with let n be even. So that means we can write n as 2k, where k is an integer. So we'll substitute, so instead of 13n plus 4, that's going to be 13 times 2k plus 4. And so this is 26k plus 4. I can factor out a 2, which tells me that 13n plus 4 is even. Now for the second part, we're going to assume that 13n plus 4 is even. And then we want to prove that n is even. But instead, we're going to assume that n is odd. So suppose n is odd, and we're going to come up with a contradiction. We can write n as a multiple of 2k plus 1, where k is an integer. So when we substitute that in for n, we have 13 times 2k plus 1 plus 4, which is 26k plus 13 plus 4, and that's just 26k plus 17. Obviously, 26k is even, but 17 is odd. So that means that 13n plus 4 has to be odd, because an even plus an odd is an odd, which contradicts the assumption that 13n plus 4 was even. So there's a contradiction here. So the assumption that n is odd is false, which means n must be even. And that completes the proof.